Okay, for number 1, to combine like terms, we're going to first find like terms. So this and this are like terms. 8 minus 5 is 3, x squared. This and this are like terms. That adds up to a negative 6, x. And this are like terms. That adds up to a positive 4. Okay, when we're looking for like terms here, this and this are like terms. That adds up to a negative 1 x squared, but you don't write the 1. It's just negative x squared. And then this and this are like terms. That adds up to a positive 8x, negative 9 minus 1. And finally, this and this are like terms. That adds up to a positive 8. Combining like terms, there are no other x cubed, so that's part of our answer. And then we have this, there's no other x squared, so that's part of our answer. And then this and this are like terms. That adds up to a positive 5x. And 1, 2, 3, 4. That adds up to a negative 6. Okay, here, this and this are like terms. That adds up to an 8x squared. And this and that add up to a negative 7x. And that add up to 0. So you don't write anything there. That's just our answer. Now, to get rid of a parentheses, you multiply what's outside of it. And there's a positive 1 here. When you multiply positive 1, it just stays the same. So these parentheses just disappear. And so do these, because when we distribute a 1, we just stay the same. And then we have this and this turns into a 6x. And this, and this turn into a negative 2. Now, you could have just done it right from here. You didn't need to rewrite this step. These parentheses are redundant because if we take a positive 1 to distribute it, we end up with 3x minus 5. But then if we take this negative and distribute this, it flips the signs and we get negative 4x plus 2. And then this and this add up to a negative 1x, and this add up to a negative 3. These parentheses are redundant, so I'm just going to ignore them as if they're not there and combine like terms. This and this add up to an 8x squared. This and this add up to 0, so it's not included. And this add up to a positive 2. And that's it. Now these parentheses are redundant. If we took a positive 1 and distributed it, it just stays the same. But this negative distributes, and we'll get negative 3x squared plus 9x minus 5. And then this and this are like terms, and those add up to 2x squared. This and this add up to a negative 1x, and this add up to a negative 3. F of negative 2 is replacing x with negative 2. So this is our f function, so we're going to have, this is equal to 4 times negative 2 plus 7, or negative 8 plus 7, which is negative 1. This is our g function. G of negative 3 is replacing negative 3 where we see x. So here we have negative 3 squared plus 3 times negative 3 minus 5. This is a positive 9 minus 9 minus 5, which adds up to negative 5. This is our f function. F of this, we're replacing this wherever we see the x. So this is going to be equal to 4 times x, which is a minus 4, plus 7. Distribute this, and we get 4a minus 16 plus 7, which is 4a, that's a minus 9. Make our a's look different than 9's. That's it. This is our g function. Here's our g, and so we're going to put 2 in for x. So this is going to be equal to 2 squared plus 3 times 2 minus 5, which is 4 plus 6 minus 5. 10 minus 5 is 5. F plus g of x, we're just taking these two functions and adding them up. So this is going to be this plus this. So 4x plus 7 plus x squared plus 3x minus 5. This doesn't combine with anything. this and this are like terms. Those add up to 7x. And this add up to a positive 2. F minus g of 2. Now we can subtract the functions first and then evaluate it too, or we can find f of 2 and g of 2 and subtract the results, and that's what I'm going to do. So f of 2 is equal to, I'm replacing this with 2. So we have 4 times 2 plus 7, which is 8 plus 7, which is 15. G of 2 is going to be equal to, replacing 2 here, so this is 4 plus 6 minus 5, which is 5. So f minus g of 2 is equal to the f function at 2 minus the g function at 2, which is 10. F plus g of x, here are our two functions, so at x we're just adding the functions. So this is going to be x squared plus 4 plus 3x minus 5. And then this doesn't combine with anything, neither does this, but this and this add up to a negative 1. We can either evaluate f at negative 4 and g at negative 4 and add the two results, or I can simply, because we already know what f plus g is, I can plug that into this. So since I've already done this, let's do that. So this at negative 4 is 16, positive 16. This is negative 12 minus 1. 16 minus 12 is 4, 4 minus 1 is 3. I also could have done f of negative 4, which is 16 plus 4, or 20. Then I could have done g of negative 4, which is, putting it in there, we get negative 12 minus 5, which is negative 17. And then f plus g at negative 4 is adding these two things together, 20 plus negative 17, which would also give you 3. Since we had already done this work, I decided to do it that way. F times g of x is taking this and multiplying this. So I'm going to have x squared plus 4 times 3x minus 5. So if I FOIL this, my first is 3x to the third. My outer is this times this, which is negative 5x squared. The inner is this times this, which is a positive 12x. And the last is this times this, which is a negative 20. And there are no like terms here, so that's our final answer. Fg of negative 3 is, I could either plug in the negative 3 into this because that's already multiplied Fg, or I can find f of negative 3 and g of negative 3 and multiply the results. And that's what I'm going to do, because if I made a mistake here and I plug this in, I'm going to have a mistake. So I'm going to do them separately. So I'll say f of negative 3 is equal to negative 3 squared is a positive 9. Positive 9 plus 4 is 13. G of negative 3 is, plugging in negative 3 here, negative 3 times 3 is negative 9, and minus 5, which is negative 14. So Fg of negative 3 is the product of those. 13 times negative 14, which turns out to negative 182. F minus g of negative 2, I'm going to evaluate each of these functions at negative 2, and then I'm going to subtract the results. So f of negative 2 is equal to negative 2 squared is positive 4, and 4 plus 4 is 8. G of negative 2, plugging in a negative 2 here, negative 2 times 3 is negative 6, minus 5 is negative 11. So f minus g of negative 2 is the f function at negative 2 minus the g function at negative 2. This turns into a plus, so we have 8 plus 11, which is 19. F minus g at negative 5, well, f of negative 5 is equal to negative 5 squared is a positive 25 plus 4 is 29. G of negative 5 is plugging in a negative 5 here. That's a negative 15 minus 5, which is negative 20. So F minus G of negative 5 is 29 minus a negative 20, which is a positive. This is adding, right? So we have plus. So that's a 49. I'm going to put this in slope-intercept form. This r y equals mx plus b. So here's our b, which is our y-intercept. And then our slope is 1/2. So we're rising 1 and running 2. Rising 1 and running 2. And then we'll grab a ruler. Put arrows on either side. And then it asks for f of 4. Well, the ordered pair with an x value of 4 is here, and the corresponding y value is negative 1. So this has a negative 1 y value. So this is equal to negative 1. This is in slope-intercept form, y equals negative 2x plus 3. So our y-intercept is positive 3, and our slope is negative 2 over 1. So because it's negative, I'm going down 2, but I'm running 1. And I'll grab a ruler. Put arrows on either side. And f of 2, the x value of 2 is right here. The corresponding y value is again negative 1. That's the point we're talking about. So this is also negative 1. Okay, when we're multiplying these, negative 5 and positive 3 multiply to negative 15, and then we have x to the positive 5 plus 3 is positive 8. When we multiply this, we're going to have to distribute this. And then when this times this, negative 4 times 2 is a negative 8. And we have x to the 1 and 5, 1 plus 5 is 6. And y to the 3 and 3, 3 plus 3 is also 6. And then we're going to have a plus because negative times negative is a positive. 4 times 4 is 16. And we're going to have x to the 1 and 1 is 2. And y to the 3 and 1 is 4. This is a binomial times a binomial, so I'm going to FOIL this. The first is x times x, which is x squared. I should do it here because I have some work to do. And then the outer is this times this, which is a positive 2x. The inner is negative 3 times x, which is a negative 3x. And the last is negative 3 times positive 2, which is a negative 6. And then this becomes that. These two combine to become a negative 1x, and this is all by itself. So here I'm going to FOIL. My first is 4x times 3x, which is 12x squared. The outer is 4x times negative 1, which is a negative 4x. The inner is negative 3 times 3, which is a negative 9x. And the last is negative 3 times negative 1, which is a positive 3. This doesn't combine with anything. This and this add up to negative 13x, and this is all by itself. Now this is not a binomial times a binomial, so I'm going to have to multiply like this. I'm going to have to take this first term and distribute it through. When I multiply this times this, I get 3 times 2 is 6, x to the 2 plus 2 is 4. And then when I multiply this times this, I get negative 15x cubed. And when I multiply this times this, I get positive 12x squared. And now I'm done with that. I'll move on to the 2, and I'll distribute that through. When I multiply by this, I get a positive 4 x squared. Oops. So that's going to go here. And then when I multiply by this, I get a negative 10x. And when I multiply by this, I get a positive 8. And when I add these together, we get This adds up to 6x to the fourth. This adds up to negative 15x cubed. This adds up to a positive 16x squared. This adds up to a negative 10x. And the last is positive 8. We could FOIL this, but there's a shortcut. When you see conjugate pairs, which is the same binomial with opposite signs in there, it's always the first item squared minus the second item squared, and that's it. Okay, this polynomial times this polynomial, I'm going to have to do this systematically. So I'm going to start with this x squared, and I'm going to distribute this through. When I multiply by this, I get x to the fourth power. When I multiply by this, I get negative 5x cubed, and when I multiply by this, I get a negative 3x squared. And then I move on to the 3x, and I distribute that through. When I multiply by this, I get a positive 3x cubed, and I'll put that here. When I multiply by this, I get a negative 15x squared. And when I multiply by this, I get a negative 9x. And finally, I'll take the positive 2 and multiply that through. When I multiply by this, I get a positive 2x squared. When I multiply by this, we get a negative 10x. And when I multiply by this, I get a negative 6. And then I'm going to add these all up. This first column adds up to x to the fourth power. This adds up, negative 5 plus 3 is a negative 2. This column adds up, negative 3 and 15 as negative 18 plus 2 is a negative 16. This column adds up to a negative 19. And this adds up to a negative 6. This is a binomial times a binomial, so we'll FOIL. The first is 4 times 2, which is 8x squared. The outer is a positive 4x. The inner is a negative 14x. And the last is a negative 7. So this doesn't combine with anything. This and this add up to a negative 10x. And this doesn't combine with anything. Here I'm going to have to use binomial multiplication. So I'll start with the x and distribute that through. When I multiply by that, I get x cubed. When I multiply by that, I get negative 3x squared. And when I multiply by that, I get a positive 2x. Then I'm going to move on to the negative 2 and distribute that through. When I multiply that by that, I get a negative 2x squared, and I'll put that there. When I multiply by this, negative 2 times negative 3 is a positive 6x. And when I multiply by this, we get a negative 4. And this is going to add up to, that adds up to x cubed. This column adds up to a negative 5x squared. This column adds up to a positive 8x. And this column adds up to a negative 4. Here we have conjugate pairs. So whenever we multiply by conjugate pairs together, it's always the first item squared minus the second item squared. And that's it. This is a perfect square binomial. So you can either FOIL this, multiply it out like this, and then FOIL, or use the shortcut. The shortcut is the first item squared twice the product of the two. Now the product of these two are positive 10x, so twice that is a positive 20x, and then it's the last item squared, which is a positive 25. Now you get used to this shortcut because you'll use it so much, but so you don't really have to do this, but if you forget the formula, just do this FOILing, and after you combine like terms, you'll end up with that. So again, I have a binomial squared. I could either write it out twice and FOIL it, or I can use the shortcut. The shortcut is the first item squared, then twice the product of the two. The product of the two is negative 12x, and twice that is negative 24x. And then the last item squared, negative 3 squared, is a positive 9. Notice that this is always a positive because it's what if no matter if this is positive or negative, when you square it, you get a positive. Okay, Chad invested $84,000 in 2 accounts. One account earned 5% and the other earned 7%. You can make a chart if you want. I'll just say X equals the amount invested at 5%, and Y is the amount invested at 7%. Now, here's my two equations. The first equation is the total amount invested, which is a sum of these, is this. So X plus Y is equal to 84,000. The second equation is that we make this much in interest. So if I take the amount invested at 5% and multiply by 0.05, this represents the amount of interest that you're making in this account. If you add that to the amount of interest in this account, which is 7% times Y, 7% is 0.07 times Y, you're going to get the total amount of interest overall. Because this works because the amount you invest times the rate is equal to the interest. So these two added up is equal to 4860. Now, I'm going to solve this by substitution. So I'm going to solve this equation for either X or Y. It doesn't matter which. So this is going to be, let's say we solve for Y. So Y is equal to 84,000 minus X by moving this over to the other side. So now I'm going to take this Y and plug it in right here. So this is 0.05X plus 0.07 times X, or Y, which is 84,000 minus X, is equal to 4860. Now I'll distribute this and I'll grab a calculator. 0.07 times 84,000 is 5880 minus 0.07x is equal to 4860. Combining like terms, this and this add up to a negative 0.02x. And I'm going to move this over to the other side, and I'll get 4860 minus 5880, which is a negative 1020. So now I'm going to divide each side by negative 0.02. And I get X is equal to positive 51,000. I just found X, which represents the amount invested at 5%. To find Y, this is going to be 84,000 minus that. So 84,000 minus 51,000 is 33,000. So I'm going to write down the answer as Chad invested 51,000 at 5% and 33,000 at 7%. That's it. Okay, Leslie sold tickets to raise money for the Punahou math team. She sold 94 tickets altogether. Some of the tickets were for boxes of chocolate that cost $9 each, and some for hard candies that cost $6 each. She raised a total of this much money. So let's start with writing defining our variables. Because they're selling tickets for chocolate and hard candies, I'm going to say C equals the number of chocolate tickets, and H equals the number of hard candy tickets. And here's the equations. One is that she sold 94 tickets, so these added up have to be 94. The second equation is that she brought in a total of $636. So chocolate tickets cost $9 each. So 9 times C plus the hard candy tickets cost $6 each. So that's going to be 6 times H. That's going to add up to $636. And again, I'm going to solve this by substitution. So I'm going to take this and solve for H or for C. Let's solve for H. So we have H is equal to 94 minus C. I get that by moving the C over to the other side. And then I'm going to take this h, which is 94 minus c, and plug it in right there. So this equation is 9c plus 6h, which is 94 minus c, is equal to 636. Now distribute this. Now grab a calculator. 6 times 94 is 564. Minus 6c is equal to 636. Combining these like terms, that's 3c, is equal to, and I'm going to move this 564 over, 636 minus 564 turns out to 72, so c is equal to 24. C represents the number of chocolate tickets. Hard candies is going to be solved here. H is equal to 94 minus c, which is 70. So, Leslie sold 24 boxes of chocolate and 70 boxes of hard candy. And that's it.